Hello, I'm Roman. Welcome back to the series of the videos Learning Go, where we're using this tour of the Go, the official guide from the Golang developers, and we going through it and learning Go. So in the previous video, I think I finished with, I need to understand where am I? Yes, I finished with the basic chapter and started with the method and the interfaces. So yeah, let's go. We checked what are the methods are the functions, methods continue, and blah blah. So right now, point receivers. Let's go. You can declare methods with a pointer receiver. This means the receiver has the literal syntax star t for some type t. Also, t cannot itself be a pointer to, such as reference to pointer to the integer. For example, the scale method here is defined as pointer to the vertex. This one. Methods with pointer receiver can modify the value to which the receiver points, as scale does here. Since methods are often need to modify the receiver, pointer receivers are more common than value receiver. Try removing start from the declaration of the scale function on line 16 and observe how the program's behavior change. With the value receiver, the scale method operates on a copy of the original vertex value. This is the same behavior as for any other function argument. The scale method, such as a pointer receiver, to change the vertex value declared in the. So basically, what I understand, this declaration is just another kind of function parameter. You know, it's like in the, where is it, in the Python, when you declare a method, you always define self as the first argument in any function. I think that's in the Python. So this is kind of the same. The only difference here, for example, that in the vertex, in the ABS, the vertex is passed as the value or reference, how it's called, the value receiver, which means that it's when I'm accessing the values, I'm accessing the copy of the original kind of struct object that where we applied this ABS func. And with the pointer receiver, we can actually change the values. For example, I can do this. It won't make a difference in this case, so that still will be 15 scale and ABS. But if I will change this one, that will be like 3 by, yeah, it will be different value. Yes, not the problem. And the reason that works is that it changes the copy of the vertex, but in the end, the original V is the same. So for example, if we will print it here, actually we can print the ABS and we will see that it will be 50, but when we call it here, it will be 5. Pointers and functions. Here we see the ABS and scale methods are rewritten as the functions. Again, try removing the star from the line 16. Can you see why the behavior changes? What else did you need to change for the example to compile? If you're not sure, continue to the next chapter. We're changing this one, and if I will run, it will scream at me at this line. That's because here we're passing, we're taking the reference of the pointer to the V. But since I changed the declaration of the function, it should scream at me because, yeah, I cannot use the value of a type effect as the pointer to the vertex as the vertex value. So if I will change it here, yeah, but again, it prints 5. And the reason to this, because again, we're changing the copy. We're not changing the argument. Well, we're not changing the variable that was passed in, right? Methods and pointer indirection. Compared to the previous two programs, you might notice that functions with a pointer argument must take a pointer. Yes, this is what I'm talking. While methods with a pointer receiver take as a value or a pointer as the receiver when they are called. While methods with pointer receiver take either a value or a pointer. Oh, yeah, so I can call this, I can call a method with a pointer receiver both on the, how's it called? It's either a value or a pointer to the value, and they both fine. But the statement v.scale 5 for this one, even though v is the value and not the pointer, the method with pointer receiver is called automatically. That is, as a convenience, Go interpret the statement as this one, so it actually automatically takes the pointer of the v and calls the scale, since the scale method has a pointer receiver. So I think this is the, not the optimization, like the compiler thing, just for the convenience, so we don't have to remember where you have the pointer receiver, where you have the value receiver. You just called it as a normal method with a dot, method pointing in direction 2. The equivalent things happen in reverse direction. Functions that take a value argument must take a value of the specific type. Okay. While methods with a value receiver take either a value or a pointer receiver is when they called. In this case, the method p.abs is interpreted as an unwrapping, but it still be the same, meaning that the methods that's declared for value receiver will operate on the copy and not on the reference. Choosing the value of pointer receiver. There are two reasons to use the pointer receiver. The first is so that the method can modify the value that its receiver points to. The second is to avoid copying the value on each method call. This can be more efficient if the receiver is a large struct, for example. In this example, both scale and ABS methods with a receiver type star vertex, even though the ABS method doesn't need to modify its receiver. In general, all methods on a given type should have either value or pointer receiver, but not a mixture of both. We'll see why over the next few pages. Okay. Interesting. Interfaces. Interface type is defined as a set of the method signatures. A value of an interface type can hold any value that implement those methods. A value of the interface type can hold any value that implements those methods. And that's what's kind of not very... This is the thing that I kind of was confused at first when I started to work with the Go. Like, for example, in the Swift and like in the C#, the languages that I worked with, you need to write somewhere an explicit, what's called, not inheritance, conformance to the specific like protocol interface, whatever you call it. Even for example, you have a struct or you have a class that implements all of those methods, you still cannot use this type inside an interface variable until you write an explicit conformance. But in the Go, all you just need to do is to have the same, all of the functions from the interface implemented for the specific type, and that's it. And yeah, I just found it confusing. I'm not saying that's good or bad. It was just, unusual to work with. Yeah, so here's an error in example 922. Vertex doesn't implement the absor because the ABS method is defined on the wait. So we have the absor. Let's take the ABS, can't use the variable. Vertex does not implement. And okay, so I think we change it like this. That should work. Okay. But where? Where is it? But if I will return, then I will do something like this. Will work? Can it use my float? Doesn't implement. Oh. This. I don't need my float. In the following. Okay. Will it work? Can't use v as the absor. Version doesn't implement absor. There's a pointer to interface. Ah, okay. But how I can... Okay, maybe we'll go next. I think there should be... I remember there is a way to have a pointer receiver for the method with the pointer for the interfaces, but okay. I will... Interfaces are implemented implicitly. A type implements an interface by implementing its method. There is no explicit declaration of intent, no implements keyword. Implicit interfaces decouple the definition of an interface from its implementations, which could then appear in any package without prearrangement. That was actually interesting because as it's written here, for example, there is a package that takes some interface and an input, and if I'm implementing some struct, implementing a type that has such methods, you don't have to implement it. And for example, you can actually combine two different third-party libraries if the function types match. The one takes an interface, the second one produces some methods, and if they match, then you can just take one and pass into another. You don't have to extend it somehow, right? Interface values. Under the hood, interface values can be thought of as tuple of a value of a concrete value type. Interface value holds a value of a specific underlying concrete type. Calling a method on an interface value executes the methods of the same name on its underlying type. Okay, we have an interface with the function m. Okay, so it explains this hello. So this is the struct, this is the float, and this is the type. So there is a reference to the t, there is type f, and yeah, when I call big M via interface, it just calls the underlying function of a concrete type. Interface values with new underlying values. If the concrete value inside the interface itself is nil, the method will be called with a nil receiver. In some languages, this would trigger a null pointer exception, below Java or C#, or any other, like most of the programming languages, I guess. But in the code, it's common to write methods that gracefully handle being called with a nil receiver, as with the method m in this example. Note that an interface value that holds a nil concrete value is itself a non-nil. An interface value that holds a nil concrete value itself is not. So so we have if t nil. Okay, we have the bar describing the interface. We have the reference to the t not created, so it will be nil. Then we assign the value of the interface to the t, which will be nil, but it knows that it's a nil value. It's a nil value, but it knows the concrete type under the interface. And then we call the m. Okay, so we called the m on the I, which used to be t, and it calls this function, and we can check that it's nil. So it's okay. Yeah, this is... So we can call methods with a pointer receiver on an empty, on an empty value, and we can process it. Well, interesting. I mean, I'm very curious where you can use it in the production. I mean, what's the profit of having such thing? Maybe you know the examples and you can tell me, because at least currently I have no idea where I would use the code structure like this, because yeah, really no idea. But it's an interesting approach. A nil interface value holds neither value nor concrete type. A nil interface. Calling a method on a nil interface is a runtime error because there is no type inside the interface tuple to indicate which concrete method calls. So if the interface is really empty, so we do not assign anything to it that should call the crash. Yeah, runtime read valid member address and nil point of difference. Okay. The interface type that specializes zero methods is known. The interface type that specifies zero methods is known as an empty interface. An empty interface may hold values of any type. Every type implements at least zero methods. Like, okay, yeah. An empty, it's like, well, it's not the void. Like in Swift, you could have any object for the classes that could hold. Well, okay, it's still not the same. Yeah, I couldn't come up with a better alternative. An empty interface may hold values of any type. Empty interfaces are used by code that handles values of a known type. For example, if empty print takes any number of arguments of the type interface. Really? You mean any? Oh, okay, any is actually an empty interface. Okay. Okay, so we're describing the empty interface, and there is no value inside, and there is no type inside. Once we assign the value of 42, we can see that it's an integer under the hood, and there is a value 42. And if we have the string, that's the same string and value. A type assertion provides access to an interface values underlying concrete type. So yeah, okay, it's called type assertion, but basically it's kind of like a downcasting. Yes, we do not have the inheritance here, but you could have the composition of the structs and interfaces, and you can check for part of it, I think. This statement asserts that the interface value I holds the concrete type t and assigns the underlying t value to the variable t. If I doesn't hold the t, this statement will trigger a panic. To test whatever an interface value holds a specific type, a type assertion can return two values: the underlying value and the boolean value that reports. Okay. I'm curious how they implemented, this behavior that if you ask for one value, then if you ask for one value, you kind of trigger a panic. I believe it will just crash the program. But if you ask for the two values, so you are not ignoring it. Or actually, you can ignore it, I guess, with the underscore, but the reason that you are asking for it, then it doesn't trigger the panic. Interesting. Can you do the same for your own functions? If I hold a t, then t will be underlying value and the k will be true. If not, awk will be false and t will be the zero value of the type t and no panic occurs. Note the similarity between the syntax and that of reading from the map. And what's the similarity? I'm not sure what they mean. the string, not float. Yeah, but what if I do this? It will print 0, right? Yes. Okay, it prints 0 because here it's actually a false. And the variable takes the value, like an empty value of the concrete type, which for the float is 0. This is why we have 0. Okay, type switches. Type switch is a construct that permits several type assertion in the series. A type switch is like a regular switch statement, but the case is in a type switch specific types, not values, and those values are compared against the type of the value held by the given interface. So okay, we can take a type switch. Oh, so it's basically if I want to. Okay, basically I can. I will tell the scary things, but how's it different from some? Look, I mean, if you provide an API like this, how is different from I don't know some dynamic type language? If you can, just expose an empty interface, and then you will have to do the type checks under the hood. Okay, a type switch is a regular switch statement, but the cases in a type switch specify types, not value, and those values are compared against the type of the value. So yeah, basically I can pass an empty interface. Oh, not specifically an empty interface, actually. I can pass the concrete interface that is implemented by different types, and I can type check against those types. Declaration in a type switch had the same syntax as the entire assertion, but the specific type T is replaced with the keyword type. This switch statement tests whether the interface value I holds the value of the type T or S. In each of the T and S cases, the variable V will be the type of T or S respectively and hold the value held by I. In the default case, where there is no match, the variable V is of the same inference type and value as I. What does that mean? I don't know about the bool type. Okay. One of the most ubiquitous interfaces is a stringer divided by stringer, defined by the FMT. A stringer is a type that can describe itself as a string. The FMT package and in many others look for this interface to print values. Oh, okay. So it's kind of like describe methods of, like the local description, like you could have in in some other languages. But okay, so there is a blah blah blah. But if I will remove this, probably it will just print the values, right? Yes. So it's like a better way to format the description of which could be useful, not at least even for just the debugging purposes, right? So you can add some other stuff and that's it. Okay. Exercise stringers. Make the IP other type implement of empty stringers to print the address as a dotted quad. For instance, should be okay, so we have the bank IP. No. Always forget what goes first. The other, right? String, right? Return this. We'll compile. No, okay. What does it mean? We will do it in a very simple way. Right. So yeah, I can do it a loop, etc. But FMT stringer. Oh, it should be this one. Okay. Okay, let's do something properly. Go string strconf probably. Import where it's located. String conversions. Here, right? I3, wait, yet no. That should be like this, right? Is an int. Okay. Probably there is a better way. There should be a better way. Okay. Again, I'll just copy paste it because I don't see why I need to bother here with loops, etc., which can be done, but it's fine. Okay. Errors. Go program express error state with the error values. By the way, what's next? Okay, let's go with the errors. The error type is a built-in interface similar to FMT stringer. So there is a type error interface and it should return error as a string. As with FMT stringer, the FMT package looks for the error interface when printing the values. Functions often return an error value, and calling code should handle errors by testing whatever the error equals nil. Yeah, like I think this is just half of the Go's code base. You know, like if error is not equal to nil, then do something. A nil error denotes success, a non-nil error denotes failure. Okay. Okay, so what we have? We have the type myStruct, we have the when and what, then we have a pointer receiver error. What? Why it's pointer receiver here? And will it work, right? Interesting. Okay, so there is a description of the error. There is a run and it returns my error. Okay. Boom, boom. Okay, and if I recall run, okay. Copy your sqrt function from the error exercise and modify it to return error. Sqrt should return a non-nil value when given a negative number, as it doesn't support complex. Create a new type, blah, blah, and make it an error by giving methods such as error negative sqrt -2 that error returns. A call to FMT as print e inside the error will send the program into an infill loop. Can you avoid this by converting e first? Why? Change the sqrt function to return an error negative sqrt value when given. I mean, I don't have the code of this program. Okay, so but maybe I have. Oh no, I have. Okay. Okay, let's take a look. Undefined math. Why it's undefined? Yeah. Yeah, because of the -2, it cannot do this. And what error negative I'm not sure what they want. Okay, so they want me to do this, then to do this, and cannot return. Cannot return a negative number. FMT as print f and b, I think, yeah, like this, right? And if x is equal to 0, is less than 0, then we should return error, and here we return nil, and here we return 0 and error negative square from x, right? Unexpected comma after top level declaration 23. It's returning nil. Because I need to check if error was to this. If error doesn't equal to nil, then we need to this, right? Still nil. And methods such as error. Okay. FMT. But it's not nil. Wait, it returns nil. Okay, so it returns me an error. Question is why? Why there is no? Is it called? Print len. Is it called? Oh, okay, so it a call to FMT inside error method will send the program to main field. You can avoid it by converting error first. Oh, because it's okay, it's an error and it tries to print the error and then it calls kind of the same. Okay. No, okay. A little bit weird, but okay. And readers. Okay. Good time to stop, I think. Well, what do we have here? We have the readers and we have 2-3 exercises. So I think that's the good place to stop and continue tomorrow. By the way, I finally managed to record a video about neural networks from scratch series and I posted it on the main channel. You will find the link in the end of this video. It will be posted, shown as a big big thumbnail in the end of this video. But for now, thank you for watching and see you tomorrow. Bye bye.